Okay, review sheet 701, 706. It's going to be long. I have a feeling it's going to be long. So, first question, define trial. Trial is, so if you have an experiment, and let's say the experiment is to, um, the experiment is, so let me write, maybe it's easier. The experiment is to toss the coins. Toss the coins, toss the coin 50 times. So that's the experiment. The trial is the number of times we're doing this. I don't know. I'm sorry. So the experiment toss the coin, and I shouldn't have written 50 times. So the experiment is to toss the coin however many times, right? And the trial is the number of times we are going to perform the experiment. And the sample space is all the possible outcomes. So in this particular um, experiment, the sample space is either going to be heads, right? So it's a coin. So it's going to be heads or tails. So the sample space lists all the possible outcomes. So we should just definitely should know what these are. So all these questions in one shape or form are going to be on the test. The probability of selecting a girl from class 801 is 3 out of 11. So the probability of selecting a girl, obviously randomly, right? Let's say their names are in the hat, all the students in the class, names in the hats, and the probability of getting a girl is 3 out of 11. The probability of not selecting a girl, which means I'm going to select a boy, obviously has to be the complement of that, which is 8 out of 11, right? I have a 3 chance out of 11 to select a girl, which means I have a 8 out of 11 chance of not selecting a girl. Coin is tossed 7 times. It lands, so it lands on heads. And then you throw it again. Heads, heads, heads. 4, 5, 6, 7, right? And then you're going to toss it one more time. What will be the probability that the next coin will land on tails? So what's the probability of this coin on the 8th time landing on tails? Well, it's 1 out of 2, right? Because the past coins here, the past results of the previous 7 times that you threw the coin, it's not going to affect this one. So on the 8th time you throw the coin in the air, the probability of tails, it's still going to be a half, right? It's not going to change. 4, there are 50 cars in the parking lot. 15 of them are blue. What's the probability of the next car coming out of the lot is blue? Well, a silly question. So the probability of a blue car coming out of the lot is going to be 15 out of 40. So I think the only thing that I think you might see is that if it's a multiple choice question, you need to change that to a decimal, which is 0.3, or as a percent, 30%. So the probability of a blue car coming out of the parking lot will be 30%. So make sure that you are okay with showing them in 3 different formats. 4 out of 30 comic books that Sam owns is a Superman comic book. What is the probability that Sam randomly chooses a Superman comic book to read? So, the probability of selecting a Superman comic book, let's say she does this randomly, it's 4 out of 30, which reduces 2 out of 15. And again, 2 divided by 15 is 0.3 bar notation, or as a percent, 13.33%. Okay. Which number does not represent the probability event? So remember, an event goes from impossible over here all the way to possible, certain, or something that will happen for sure. And the numbers are, if from 0, right, all the way to 1 in the decimal format. And this would be half, 0.5. So 0.5 would be half and half, right? Likely as not. So there's a 50% chance. So -3, do you see -3 in this number line? So this does not represent the probability of an event. 1 does. If you see 1, it means it's for sure going to happen. 1.5 is somewhere over here. There's nothing bigger than certain. If it's certain, it's 100%. There is no 1.5, so that's gone. 0.05, it's right here. It's really, really, really right there. 0.05. There's a very, very small chance of happening, but it's on this number line. So this one, let me erase this. So this one does not represent the probability of an event. This one does not represent the probability of an event. And 0.7 would be around here, which is the same thing as 70%. And that's on the number line, so that's okay. So this is okay, this is okay, this is okay. -3 and 1.5 does not represent. Number 7, Tim has an 80 out of 40%, 80 out of 40 probability of getting the answer correct, the correct answer. So write the probability as a percent. 8 out of 40. Let's simplify to 1 out of 5, which as a decimal becomes 0.2. And remember, we're moving that 2 spaces to the right, to the decimal 2 spaces to the right. So that becomes, he has a 20% chance of getting it correct. Larry has a spinner equally divided and labeled with the numbers 1 to 5. So let's create a spinner. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Obviously, it's an equal. Forgive my picture. The spinner spun 80 times. How many times do you expect to land on even, and then on 2, and then on 4, 5? Well, what's the probability of getting an even? Well, there's how many even numbers? 2 and 4. So the probability of getting an even, right, is 2 out of 5. And if we use that to predict, we multiply that by 80, and 2/5 of 80 would be 160 divided by 8. So you would expect it to land on even 20 times. What's the probability of landing on 2? The probability of landing on 2, if you look at this, there's, well, 1 out of 5 chance of landing on 2. But we're looking at how many times out of 80 spins it would land on 2. Well, multiply that by 80. And we would expect it to land it on 2 16 times. And the last one, probability of 4 and 5. So what's the probability of landing on 4 or 5? It's 2 out of 5, which you notice we already did on top. So 2 out of 5, and if we spin this 80 times, we're going to expect that it lands on 4 or 5, a total combined of 16 times. 9. Kim has a spinner with 3 colors, so it's always nice to draw it out, right? So here's my spinner. 3 colors: green, red, and blue. And she has a die which has 8 sides. 1, 2. I'm not going to draw an 8-sided cube because I don't know how to. 1, 2, 3. But just to tell you, there are 4, 5, 6, 7, 8. 8 sides, each of them labeled 1, 2, 3, 4, 5, 6, 7, 8. What's the probability of landing on red and rolling a multiple of 2? So we want to get a red, and I'll put that in capital letters, a multiple of 2. So if she does both things, she wins. So the probability of landing on red is 1 out of 3. And we're going to multiply that. What's the probability of landing on multiple of 2? Well, multiples of 2 are 2, 4, 6, and 8. So there's 4 out of 8 chances. Let's multiply both of them. 4 eighths, I can simplify this to 1/2. So the probability of both of them happening is 1 out of 6. So far it looks pretty easy. If you had a spinner with 3, with 3 equal sides labeled 1, 2, 3, how many times would you expect to land on 3 after 40 spins? Alright, so you have, again, a spinner. Right, you have a spinner, and it's labeled 1, 2, and 3. If you were to do this, spin this 40 times, how many times would you expect it to land on 3? Right here. Well, the probability of landing on 3 is, this case, 1 out of 3. And if you're going to make a prediction, right, you're going to multiply 1/3 times 40. Right? And you're going to get a decimal, 13.33333 forever, 13 bar notation. You can't have 13.3 spins, right? So we're just going to say about 14 times out of 40 you would land on 3. Okay. 11, a spinner was spun. So this spun and the results were recorded right there. When you read this, you should know that this is experimental probability, right? So there was a spinner, it landed on 10, 14 times, red 14 times, yellow 14 times, and blue 6 times. So basically, we're basing this on an experiment. So what was the probability of landing on red? Based on this experiment, how many times did they spin this? Well, there were 10 here, 14, 6. So if I add this, a total of 30 spins, and out of the 30 spins, so that goes here at the bottom. Out of the 30 spins, the probability of landing on red was 10. So 1/3 of the time in our experiment landed on red. So that would be the probability. What's the probability of guessing the correct answer on multiple choice question with 4 answers? Well, that would probably be your case here. If you get stuck on a question, on a multiple choice, and you have A, B, C, D, and you have to choose the correct answer, well, there are 4 choices, and the probability of getting the correct one, that's the correct one, would be, let's say, well, there's only one correct answer, so the probability of getting that correct answer would be 1 out of 4. 13. What's the probability of selecting a blue from the marble, a blue marble from the bag? Well, let's see how many there are. First of all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Probability of getting a blue is going to be something out of 12. And then hopefully this is a little bit clearer to you. And the probability of getting a blue, there's 1, 2, 3, 4, 5. So without looking, the probability of getting a blue is 5 out of 12. What's the probability of random selecting the letter R? Well, is there a letter R here? Well, yes, there is. So the P of R, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. And the probability of getting an R is 1, 2. 2 out of 10, or 1 out of 5, or if you change that to percent, 20%. What's the probability of spinning a number less than 6? Okay. P less than 6. Well, how many numbers in total are there? 1, 2, 3. First of all, there's 8. And the probability you will land on a number less than 6. Less than 6 would be 5 is okay. 4, 3, 2, 1. So there's 1, 2, 3, 4, 5 choices. The probability of you achieving that would be 5 out of 8. Sam picks a card, records the results, and returns it to the box. Okay, so he's going to take it and look at it and put it back. On the 9th time, so he already did this 8 times. We don't know what the previous results are, but on the 9th time, before he does it, what's the probability of getting the letter G? Well, whatever he got in the previous 8, it's going to have no relevance here. It's going to, right? It's not influencing anything. So the probability of getting a G on the 9th time would be, well, there's only one letter G. And it would be 1 out of 1, 2, 3, 4, 5, 6, 7. So he has a 1/7 chance of getting a G on the 9th time. Or even on the 200th time, it wouldn't matter. That probability would be still 1/7. In a survey, 100 people were asked to name their favorite Independence Day side dish. What's the experimental probability of macaroni being someone's favorite side dish? So we want the P of macaroni. So according, and again, this is experimental, so based on an experiment that happened, right, which in this case was a survey, out of 100 people, how many said macaroni salad? 12 over 100. Which you can simplify to 6 over 50 and then 3 over 25. Or you can change that to percent later, to 12% if you so choose, depending on what kind of question or what kind of multiple choice question answers you have. Okay. What's the probability of tossing a coin and landing on tails 3 times the most? So you want P of tails and tails and tails. So what's the probability of that happening? You getting 3 tails in a row. Well, the probability of the first tail is half times the probability of the second tail is going to be half again. And the probability of the third tail is going to be half again. So the probability of you accomplishing this, well, multiply all of them, will be 1 on top and 8 at the bottom. 1 out of 19. What's the probability of the spinner landing on an even number and landing on brown? Okay, so let me write this down here. P of even and brown. So again, imagine if you had to accomplish those 2 things, what would be the probability of you accomplishing those 2 things? The probability of an even number, landing an even number, well, there's 1, 2, 3 even numbers, so you have a 3 out of your 6 sides, 6 chance of getting an even, times the probability of that spinner landing on brown is 1 out of 3. Let's simplify. You can cross these 2 out. Simplifies to 1. Do the 1 here, 1 here. And then you can multiply out and you get 1 out of 6. The probability of you achieving that is a 1 out of 6 chance. If the probability of winning is 7 out of 8, then it is likely, unlikely, certain, likely as not, or impossible. So again, I'm going to draw it out, right? So this is impossible, right? So let's not use numbers. Let's go with impossible. Certain goes all the way here because that's for sure. Unlikely would be somewhere over here. Likely would be somewhere over here. Likely, it's not 100%. So likely is there, unlikely is here. Certain is already there. Likely as not is just in the half. Likely as not, it can happen or it cannot happen. But 7 out of 8, pretty good chance, right? And even if you divided that, 7 divided by 8, you get 0.87. You're going to get 0.875 in your calculator. If you move the decimal 2 over, it's an 87.5% chance of happening. So that's not a bad chance. It's a pretty good chance that it will happen. So this is likely. 21. Based on this table, what is the probability of, okay, so the table below shows the different types of books sold. Based on the data, what's the probability that the next book sold will be a physics book? Right, so I guess this represents all the books that were sold to a certain point. So let me see how many books were sold so far. 44 plus 36 plus 24 plus 25. So there's a total of 129 books here that were sold. 129. 129 books were sold. And out of that, how many were physics? 25. So if a customer, the next customer came in and we wanted to predict or figure out what's the probability that the next person who comes into this bookstore buys a physics book, well, based on this, on all the customers during the day that came previously to this, prior to this new customer, the probability that the next person coming in will choose a physics book is 25. So we use the data from the survey, not the survey, from all the sales during the day. Okay, so this is again an experimental. It's based on something that happened, and this was based on the sales that occurred during the day. So that's the probability. 22. Draw tree diagram. This will definitely be there. Exactly. You're going to be asked to draw one. Okay, so make sure you're very comfortable drawing one. So let's draw one. So here is a draw tree diagram that shows all the possible combination of lunch meals that can be bought if you choose one from each category. Answer the questions below as well. So you need to answer So let me try to bring everybody to the same page. Put that there, space. Bring this down just a little bit. Okay, so let's see if I can do this. No, sorry. Just make sure everything's on the same page. All right, so let's try to do that. So, tree diagram, and I'm going to abbreviate. Here's my starting point, and the first thing we can choose is a salad. Or you can choose a soup. Or you can choose just to eat bread. That's your first choice. Now, so let's stick with the salad. So let's pretend you chose salad. Well, with your salad, you can have beef, or you can have fish. But let's say you said, I want salad with beef, and then if you're having salad and beef, you can have a choice of coffee or tea. So, and then if you had the salad and fish, well, with the fish, you can either have coffee or tea as well. Soup. Let's say you start with soup and said no to the salad. Well, with the soup, you can come either with the beef or come with the fish. And with the beef, you can have coffee or tea. And with the fish, you can either have coffee and tea. And finally, with the bread, and you can see that's repetitive here, right? With the bread, you can have beef or fish, and beef with coffee, beef with tea, or fish with coffee, fish with tea. So don't forget to do this part here. I want a sample space here. Sample space will list all the possible meals. So I can have a salad with beef with coffee. I can have salad with beef and tea. I can have salad with what is it? Fish and coffee. I can have salad, fish, and tea. So this is done. Right, that section is done. Now I'm going to do soups. So I'll write SP for soup, with beef and coffee, soup, beef, and tea. I can have soup, fish, and coffee, soup, fish, and tea. And the last one at the bottom here, or I can have bread with beef, or BR for bread, beef, and coffee, bread, beef, and tea. What else can I have? I can have bread, fish, and coffee, and bread, fish, and tea. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 possible different combinations. And you already knew that because remember, we can always multiply the number of choices in each section. There were 3 appetizers times the number of entrees, which is 2, times the number of drinks. 3 times 2 is 6, 6 times 2 is 12, and we could have found the total number of outcomes doing that as well. So, but now you also have them listed. So the first question is, what's the probability that somebody who's going to come in here will buy a meal that has a soup? Well, what's the probability that somebody buys a meal that has a soup? Well, how many different meals did we say we had? We had 12 different meals. And how many of them had soup? Well, this one had soup. It doesn't matter if it was beef or coffee or tea, but as long as it had soup. So this one had soup, this one had soup, this one had soup, and this one had soup. So 4 out of the 12 meals had soup, or 1/3. You can simplify that to 1/3. So that's question 1. So question 2, what's the probability that somebody will buy something that had bread and tea? So let's look for all the combination, all the meals that had bread and tea. So again, there were 12 possible meals that we could make. And how many of them had bread and tea? So none of these were all salad, salad, salad. These were soup, 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 soup. And these had bread. So, but I want to look for something that had bread and tea. Well, you got one here. So this meal had bread and tea. And also the bottom here had bread and tea. Well, this had fish and this one had beef, but both of them had bread and tea. So the probability of someone buying something that had bread and tea would be 2 out of 12 or 1 out of 6. So definitely you'll be doing a tree diagram in the same manner here and answering questions based on that. 23. a bag has 5 red, so I'm just gonna write here 5 red, 8 green, and 3 yellow, which gives me a total of 5 plus 16 total. There's 16 total marbles in the bag. So a marble selected and then replaced, which means that if you take the marble, you look at it, and then you put it back in the bag. Okay, it's not without replacement. This is with replacement. And then the second marble is selected. So you're taking 2 marbles from the bag, one at a time. And don't forget that we're putting the marble back in the bag. Okay. So the first question says, what's the probability of getting a red followed, I don't know why I'm writing it again, followed by a red. So you're taking 2 reds followed by a red. I'm going to erase this. So what's the probability of right now going to the bag and getting a red? Well, there's 16 in total. How many reds are there? 5. You look at it, and now you return the marble into the bag, you shake it, and then you're going to take another red. Well, because it's with replacement, you still have 16 in the bag. And how many reds are still there? 5. Nothing changed. Then you just multiply, and you get whatever it is, 16 times 16. So you're going to get at the bottom 256, and at the top 25. So you have a 25 out of 256 chance of actually getting that accomplished. Second one, getting a red followed by yellow. So again, same thing. What's the probability of getting a red? Well, the probability of getting a red is 5 out of 16. You take the red, you look at it, you put it back in the bag. So we still have 16. Now you want to, for the second marble, you want to take a yellow. And how many yellows? 3 yellows. And lastly, just multiply. So now you have a 15 out of 256 chance. Last one, a yellow followed by a yellow. Well, probability of getting a yellow on the first try is 8 out of 16. You look at it, you take the yellow marble out of the bag, you look at it, and you write down that's yellow. You put it back in the bag because it's with replacement. So there's still 16 in the bag. And if you want to, oops, not 8 out of 16. Where did I get the 8 from? No, right, it's 8 out of 16, and then followed by yellow, sorry. And then now you want to take a yellow, because the first one was green, now you're going to take a yellow, and to get a yellow, it's 3 out of 16. We can, well, you have a calculator, but I would simplify 8, 16 to 1 over 2 if you can, why not? Now you can multiply, 1 times 3 is 3, and 2 times 16 is 32. So those will be your probability based on that. So remember that this one is with replacement. You're putting the marble back in the bag after selecting. Last question. The table below shows the number of books at a bookstore sold. Okay, so it's again the same table that we used prior. Shows the number of books sold at the bookstore, and I believe I just added it. Was it 129? 44 plus 36 plus 24 plus 25. That gives us that. So there were 129 books sold today, right? So if we're going to order 400 books based on these sales, how many of those 400 books would you, would you order? That would be zoology books, right? Because you want to make your order to sell based on what people are buying, right? If nobody's buying zoology books, then you're not going to order any. But apparently there were some buyers. So the probability, the experimental probability, right? Because this is something that had the experiment here was all the sales during the day. And during the day, there are 25, let me write this, zoology. So during the day, how many people bought zoology books? Right here. 24 people out of 24 books out of the 129 sold were zoology books. So now there's definitely some sales, right? So now you're making an order, and you want to make sure that you order a good amount of zoology books, not too much, not too little, just enough that, because if you don't sell it, right, you lose your money. So we're going to use this 24 out of 29. And we're going to multiply by the number of books that we want to order. We want to order 400 books. So how many of those will be zoology books? Well, take your calculator out. Enter. Enter again. So I got 74.41 books. Well, we can't order 34.41 books. Therefore, we're going to order 75 books. 75 zoology books. So on the next order of 400 books that you're going to make, 75 of them will be zoology books. And that's what I need you to write here. Okay, so you definitely need to explain all this in writing and show me the work. Okay, and likewise for the last question, show the work and explain. So again, here's my experiment. I went and I spun a spinner, and the spinner had 6 sides. 1, 2, 3, 4, 5, 6. Right, and then it landed on 1 how many times? 8 times. It landed on 2 6 times. It landed on 3 9 times. On 4 11. On 5 9 times, and it landed on 6 7 times. So I know all that. So let me see how many times did we spin this on the experiment. Well, this was 8 times. We spun this 8 times. It landed on 1 8 times. On 2 7. On 3 9. On 4 it landed 11 times. On 5 9. And on 6 7. So let's add this, and that tells me how many times. So plus 9 plus 11 plus 9 plus 7. Really? 3 plus 7 plus 9 plus 11 plus 9 plus 7. So 51 spins. There were a total of 51 spins. So out of the 51 spins, how many times did it land on 6? Well, we spun this 51 times, and it landed on 6. How many times right here? This is 7 times. 7 out of 51 landed on number 6. So if I told you I was going to do this 300 more times, spin the spinner 300 more times, how many times do you think it would land on 6? So let's do our prediction. All right, so in the prediction, I'm going to use this result here. So 7 out of 51 landed on 6, right? I can see that from my table. And I'm going to do this 300 more times. And if I do that, just use your calculator. And I get my calculator 41.17 times. So you can't have 41.17 times, but rather you can tell me that, hey, out of the next 300 times, we can expect 42 of them to land on 6. That's literally what your test is going to look like. So if you're really comfortable with this and you did well, congratulations, you have nothing to worry about. And that's it. I'll post it right now.